Welcome. The purpose of this training is to get you familiar with the benefits of adaptive and introduce you to the system. There is more detailed training available if you find you'd like to know more once we are finished. With that said, let's jump right into it. In all system designs, directivity directly affects intelligibility, localization also. Reducing destructive reflections means there will be increased intelligibility and a more direct sound experience. Not every venue will have straightforward coverage areas. Many times, complicated seating arrangements are met and need to be addressed. Where traditional systems can be complex and need to be manually or physically configured to cover an audience, adaptive systems can adapt to any seating environment with a push of a button. When complicated coverage areas come into play, resolution modeling software can be used for easy coverage shaping. Let's say you run into a scenario where audience areas need to be changed. Sometimes a venue has multiple uses where a fixed system has no flexibility to accommodate these different scenarios. Adaptive systems can utilize this entire array of resources and acoustically adapt to any changes in coverage with software control and presets. A common install challenge is height and visibility restrictions. When sightlines matter or visual impact is restrictive, adaptive systems can do much more with shorter arrays than previously possible with any traditional system. As sound system technology continues to grow, so does the complexity on how they are being used and configured. Whether for immersive system designs or simple LCR systems, adaptive arrays can easily achieve the requirements of consistent coverage for proper imaging like no other system today. Though the concept is complex, the adaptive platform takes huge steps forward in making imaging and multi-channel audio simple to implement and use. Lastly, noise control. Noise control or noise pollution has become a hot issue, especially in outdoor venues. Adaptive systems has a unique ability to focus energy only where the audience needs it and reducing unwanted noise pollution to nearby areas. Let's move on now and talk about what makes adaptive so different. Digital steering has additional acoustic benefits over mechanically tilted systems. Traditional tilt aiming introduces both unwanted destructive reflections and unwanted room excitation. These issues reduce intelligibility and sound quality. Digital steering helps to reduce destructive reflections and reduce room excitation as illustrated by the image on the current slide. This will help increase intelligibility and improve sound quality. Let's dive further into how adaptive addresses complicated seating areas with 3D modeling. You can see on the screen we have a fairly complex and asymmetrical seating configuration. Using resolution software, we are able to model this venue, then designate each surface as a coverage area. The adaptive arrays then allocate resources to best cover the space. Looking at this next model of a basketball arena, let's discuss changing the coverage requirements. Mapped out here is full coverage. Adaptive arrays are looking at every seat in the arena as a coverage area. On this slide, adaptive is only covering the bottom two bowls. Again, adaptive is able to do this without any physical configuration change. Height restrictions is a common challenge in the install world. Adaptive shines here. As a result from the driver density in both Anya and Anna, it takes less boxes to accomplish the same output and coverage versus a traditional line array. In situations where 8 to 10 line array boxes may be needed, only 4 to 5 of a similar sized adaptive line array may take its place. This makes it much easier to avoid sightline issues. A more modern, yet growing need is exploring the best way to deploy multi-channel audio. Using many of the examples above, adaptive makes a great solution in this case. Here's what we're looking for. Constant SPL at each seat from each program channel, constant tonal response or frequency response, discrete arrivals. Each program channel source should provide a single discrete event without multiple late arrivals. Adaptive checks all these boxes. Having the ability to have system processing treat two columns as one array helps dramatically in creating a uniform SPL and frequency response to every seat. This satisfies all the requirements for multi-channel audio to work well in the most difficult spaces to achieve correct imaging. Lastly, let's talk about how adaptive can help with noise control. There are many scenarios in urban environments where max output is needed in a venue but cannot spill over to surrounding neighborhoods. Using Pier 17 in New York City as an example, this venue is on the upper deck of a pier in the city. Being a premier concert destination, there needs to be plenty of SPL, but many businesses and residences are close by. Notice how the venue is relatively small, but there is a significant number of boxes. This is not for output. This is all for control. The more cells we have, the easier we can control the sound energy coming from the arrays. Here, we illustrate how SPL drops off as we leave the designated coverage zone. So how does all this work? What makes adaptive so different? To explain the system, let's first take a look back on where it comes from.